Next, I want to introduce you to modern material identification. This piece of equipment I hold in my hand is a alloy analyzer. Now, this machine has the ability basically to take an X-ray, very deep or shallow penetrating, I should say, X-ray, and from that it takes a full chemical analysis. That chemical analysis, it then compares against a database in the machine, and it'll tell you what type of material it is. If it matches one of those particular alloys. If it's not a precise match, it will go through and show you to what percentage or what it's close to, what it's very similar to. So it's an excellent piece of material, but there are some limitations. This item, when it was purchased, was a $32,000 or $35,000 piece of equipment. You know, it came in a complete case and set, very nice. This type of technology has been out for a number of years. So now there are a number of refinements that have been made. This particular model cannot tell you carbon content. And that can be very important when we start talking about our different types of steels. So the machine relies on the different chemistries, all the other alloys that make it up, not only just the carbon content to identify it. Now the other thing is it doesn't have the ability to separate out what are known the light elements, Le, when we think about the aluminum and magnesium. So it doesn't have the ability to separate out those particular elements as we look at the periodic table. Now, what it does when it lumps together all of these light elements and takes them as one measurement. Okay, the atomic weight is so light it can't separate them out, but it does lump those elements together. But through the other elements in the chemistry, it then has the ability to go again, check it against a database and tell you what it is. If it's not an exact match, it will tell you what it is closest to. So it's an excellent tool, becoming more and more standard. And again, there's been a number of refinements to it since it was first developed. But ultimately, when firing it up, just like any computer, you have to boot it up. Once it's booted, choose your app, start that app. It basically boots up. Once that's booted, then it needs to calibrate itself. So it takes this clip, which has got two discs that are made of 304 stainless steel, and as you snap it over the nose of the gun, it takes a baseline sample of that and compares it to what it knows it's supposed to be. And then will tell you, is it acceptable, is it calibrated or not, and adjust. And the higher the number that you get, the better the reading, the more accurate it is, and all is good. So standardization clip, just to save time, I've already completed that action. But what we go to, and we'll go to one of these materials, rest the gun squarely on it. And again, it does produce radiation. So it's not recommended to be holding an object and shooting it as you're exposing yourself to that radiation. So we want to go back, take that sample, standing away from it as such is perfectly safe for the way the equipment's designed. There is a display on the end of the gun, so you're not having to bend over awkwardly to look at the screen in your display. But it's got a timer. So it's taking multiple samples per second, and then it averages those results. Those results, again, then get compared against the database. So for this particular material, it tells us it's a copper titanium, which is a grade of titanium. And it tells us, again, the full chemical analysis, titanium, 98.93%, with a small content of ferrite or iron, 1.09, and it's considered to be a little high for this particular grade of titanium. And it tells you all that information graphically in the display. So, excellent tool. Again, even though there are some limitations, those limitations have been addressed in newer models. From the literature I've read, it is now capable of reading the light elements. It doesn't have to lump them. it can separate them out so you get a much more accurate reading and better overall results, and you know exactly what you have. This material, we know it's aluminum, but it is telling us it is an alloy 5086. Okay, or that's the closest. It could be a 5086 or a 6063, and it shows you and allows you to see the overall chemistry. So light elements, it tells us 99.21. So then you have your trace elements, your chromium, manganese, ferrite, nickel, and copper. But it tells us it is the closest to 5086 aluminum. So, very good. But again, you can see the benefits of this type of tool. Now it has a number of different settings. It is capable, I think, this database with different metals. It's got 350 some odd materials in the database, which cover most things that are out there. But again, it's ever changing, ever evolving, so there are more and more alloys being developed. So, you know, keeping that up to date can be very important. It is capable of having soil software, so you can take soil samples and understand what's going on in the soil. But you find this to be used a lot of times in scrap yards. What material is coming in? What scrap weight do we need to pay for this item? Is it what they say it is? So, and then we also find it being a very big part of quality assurance. Raw materials coming into a production facility. You pay for 304 stainless steel. You want to ensure that's what you get. More than just paperwork, you want to verify physically. So as you take a sample, that piece of equipment can tell you, is it truly 304 stainless steel, or did they mistakenly give you 316? It can be very different because, again, those chemistries, do they work as well in the environment and the way that part was designed? And the wrong material could lead to premature failure of that component or other problems. So ensuring the material type can be very important. And it's got a setting where if you use and you're only looking for 304, you can set it up in there as a go, no-go. So as you take a sample, it's going to give you a positive or a negative and just tell you how it compares specifically to 304. So depending, there are many different ways that this can be used. A very expensive tool, but a very nice tool. And the benefits to this can save you a lot of time and accuracy, or bad product going out the door, and which can ruin a company's reputation, or a scrapyard paying for the wrong material. So a lot of different opportunities, very important modern piece of equipment, but not everybody has, but becoming more and more widespread, and like most technology, becoming more and more